These type of problems look really simple, right? But when you try to optimize it and try to think of time efficient ways and space efficient ways, what happens? They certainly get your mind tickling, right? You start to wonder, okay, how can I improve this solution even further? I am talking about the problem number of good pairs on LeetCode. You are given an array and you need to determine the total number of good pairs that you can form. I will show you in a little while with examples what do you actually mean by a good pair. Hello friends, welcome back to my channel, a place where we explore the life of technology and make programming fun and easy to learn. First, I will explain you the problem statement and we will see some sample test cases. Next, we will see a brute force solution to the problem and see what problems you may face. Going forward, we will try to find an efficient solution to the problem and then do a dry run of the code so that all of this sticks in your mind forever. That way you will never forget it. So, without further ado, let's get started. Let us try to first make sure that we are understanding the problem statement correctly. What is given here is you have an array of integers and you have to find the number of good pairs. Now, the question comes to your mind. What is exactly a good pair? So, a pair is called to be good if they both have the same integer and the index is different. What does that mean? Let us look at this sample array. It has some integers, right? And now let us try to look at the indices of each of the element. The first condition for a good pair is that the integer should be the same. You can see that 1 and 1 are same, right? And these are the two indices 0 and 3. So we can say that one of the good pairs would be 0, 3. Now this array could have more good pairs. You can see a 1 here and a 1 here as well. And the indices are 0 and 4. So this will form another good pair that is 0, 4. Going forward, you will have one more good pair that is 1 and 1. And these indices are 3 and 4. So you can easily write down one of the good pair as 3, 4. Notice that in a good pair, the value of I should be less than j. What does that mean? It simply means that when you're finding a good pair, the first index should be smaller and the last index should be larger. So you cannot have a good pair that says 4, 0 because 4 is larger in this case than 0, although the element 1 is same. So based on this idea, this array has one more good pair and that is 3 and 3. You can easily say 2 and 5 and that will give you one more good pair that is 2, 5. So you can see that this array has a total of 4 good pairs, right? And in this question, you just need to print the number of good pairs. So you just need to print out 4 as your answer. You don't have to worry about all of these pairs. You just need to tell the number of these pairs, right? Similarly, let us look at our test case number 2. In test case number 2, we have 4 elements, 1, 1, 1 and 1. Now, all of them will form good pairs, right? And hence, these good pairs would be 0, 1, 0, 2, 0, 3. Now, the first index has to be a smaller one, right? So I will now start with 1, 1, 2, 1, 3, and then ultimately I will start with 2. So that is 2, 3. So how many good pairs did you see over here? We saw a total of 6 pairs, right? And hence, the answer to this test case would be 6. Similarly, let us look at our test case number 3. We have the array 1, 2, 3. You can see that in this array, no element is same, right? And hence, this array will not form any good pairs. So you can safely say that for test case number 3, 0 would be your answer. Now, if this problem statement is clear to you, feel free to try it out on your own. Otherwise, let us see what solutions I can offer you. First of all, let us try to approach this problem with a brute force method. That is because A brute force method can guarantee you if a solution to this problem exists. So if you have this sample array in front of you, what you can do is you can start with the first element and then compare it with each of the other element. As soon as you see a matching element, what happens is you know that this is a good pair, 0 and 3. So as soon as I find a good pair, I can write it down. I can then continue my search further, right? I started with the first element 2, 3, 1, and then I move ahead and I see a 1 again. That means I found another good pair, and this time the pair would be 0, 4. Now the array ends, right? So I cannot form any more good pairs with this one. Next, I will move on to my second element. I see number 2, and I will compare it to each of the element. I can't find a 2 anywhere, right? And hence, I cannot form any good pairs with this. Moving ahead, I see my element 3. I will again compare it with all the elements. I see a 3 again, right? And I will find one more good pair, that is 2, 5. Similarly, I will continue for each of the element and I will get one more good pair, that is 3, 4. Once you are done traversing this array, you can just check how many good pairs did you find and you can count them. This will give you 4 as your answer. This solution works and it will give you a correct answer every time. But do you see the problem with this approach? What happens if your array size is very large? What if you have all these new elements added? Then you will have to compare one with all of these new elements, right? And once you're done with the first element, you will have to do all of these comparisons with the second element also. So you can see that you are making a lot of comparisons. And hence, this solution is not time efficient. What can you do about it? Let us have a look at it. To start things off, let us take up a larger array. And this will verify that our efficient method is actually working. When you try to think of an efficient solution, try to think intuitively. You have to find the number of good pairs, right? And a pair is formed with the same integer. So this gives you a thought. If I have more count of a single integer, then more the number of pairs I can form, right? So one thought that should come to your mind is, if I can store the frequency of each integer, then it may help me somehow. So let us try to do that. I am creating a frequency array, right? And this frequency array will store the count of each integer in the array. Right now, when this array is initialized, the count of each of this element is 0, right? And what I will do is, I will start iterating my array. As soon as I see any element, for example, I see 1. So what I would just do is, I would increment the count of 1 by 1, right? Moving ahead, I see the element 2, and I will increment the count of 2 by 1. Next, I see element 3. So I will increment the count of 3 by 1. Next, I have element 1 again. So I will increment the count of this 1 by 1 again. So this becomes 2. I have a 1 again. So this time again, I will increment the count. Moving ahead, I get 3. So just like this, I will traverse through my remaining array and I will increment the count in my frequency array. Once all of this is done, it will become something like, okay, so this is my final count. I have 4 ones, 2 twos, 3 threes, 0 fours, 2 fives, and 0 sixes. And you can verify it in my original array. Now, how do you take advantage of this frequency array? If you look at the values, you know that you have 4 ones in the array, correct? And if a pair is formed of 2 integers, how many pairs can you form? That would be 4C2, right? This is the same mathematical formula that is given by NCR equals to n factorial upon r factorial into n minus r factorial. So what does this tell you? This means that you can form 4 C2 pairs with the element 1. Going forward, you can apply this same technique to all the integers. You can form 2C2 pairs with the element 2. So that would be 2C2. And then you can form 3C2 pairs with the element 3. And that will give me 3C2. You cannot form any pairs with the element 4 and you cannot form any pairs with the element 6, right? But you can form 2C2 pairs with the element 5, right? So I will also add this to my result. So in the end, we can say that the total number of pairs will be given by this formula. Once you have calculated this, this will simply return you your answer. Now, how do we write the code for this? Let us have a quick look. On the left side of your screen, you have the actual code to implement this solution. And on the right, I have a sample array that will be passed in as an input parameter to the function. Oh, and by the way, this complete code and the test cases are also available in my GitHub profile. You can check the link in the description below. What happens next is I create a frequency array that will store the count of each element. So once this array is formed, that will be something like, what this simply means is this array has 3 ones, 1 2 and 2 threes, right? And you can verify it in the original array itself. Once we have completed this for loop to calculate the frequency array, we initialize a value total count that will store the total number of pairs you can form. And to calculate this total number of pairs, I will again run a for loop. In this loop, what I will simply do is I will apply the formula nc2 to each of the elements in my frequency array. So when I run this combination formula for each of the element in my frequency array, I will get my answer as 3C2 plus 1C2 plus 2C2. And that will give me 3 plus 0 plus 1. And that turns out to be 4. This total count will be then returned as the answer. Now, the time complexity of this solution is order of n. That is because you are only doing one iteration of the array, and the space complexity of this solution is order of 1. That is because you are only using constant space. I hope I was able to simplify the problem and its solution for you. As per my final thoughts, take a moment to think, how did we come up with a solution? Instead of manipulating the array and iterating through it, what we did is we applied some principles of mathematics to arrive at a solution. Basically, if you have studied about permutations and combinations, these kind of concepts come in very handy. That is why I always say that whenever you're solving programming questions and you see some maths around it, try to go back to your fundamentals and think abstract, think out of the box. You may arrive at a solution that you might not have even expected, and that can lead you faster results. What other solutions did you come up with? What other techniques did you try? Tell me everything in the comment section below, and I would love to discuss all of them with you. You would be also glad to know that a text-based explanation to this content is available on the website studyalgorithms.com, a pretty handy website to help you out with your programming needs. You can find the link in the description below. As a reminder, if you found this video helpful, please do consider subscribing to my channel and share this video with your friends. This motivates me to make more and more such videos where I can simplify programming for you. Also, let me know what problem do you want me to solve next. Until then, see ya.